today with doing the homework from Wednesday. So the first question, 3 students are asked how many days they were late arriving to school over a 100-day period, and here are the results. Okay, so student A was late 15 days, B 8 days, and C 29 days. Estimate the relative frequency as a decimal for each of the students being late. So for student A, it's 15 out of 100. For student B, it's 8 out of 100. And for student C was late 29 days out of 100. Okay, if you type these into your calculator using your fraction button and then follow that with the SD button, you will get these into decimals because we were asked for decimals. So that is 0.15, this one is 0.08, and this one is 0.29. And that's it. That's the first question. Now, hang on. This is freezing on me, so just bear with me a second while I shut it down and then come back into it. Okay, so let's try this. So data is collected on different types of vehicles that pass through a toll bridge during a 1-hour period. The results are as follows. So 94 cars passed through, 27 vans, 34 coaches, and 45 lorries. How many vehicles passed through? So to figure out how many vehicles, you have to add these up. So 94 plus 27 plus 34 plus 45. Okay, and remember I said you should show your work. So for part A, I have 94 plus 27 plus 34 plus 45, and I'm getting 200 for that, a total of 200 cars passing through. Sorry, vehicles passing through. So what is the relative frequency of a car passing through? And we would like our answer as a fraction. Okay, so there's 94 cars out of a total of 200. Now that's fine as an answer, because it doesn't say it needs to be in its simplest form, but I'm going to use my fraction button on my calculator, and I'm going to simplify that fraction, if that's possible, to 47 over 100. Okay, so either of these answers are completely correct. Part C, what is the relative frequency? So just change colour. This is a van passing through the toll bridge, and our answer as a decimal. Okay, so 27 vans out of 200, and as a decimal, so I'm going to need to type it in like this as a fraction, and then to convert it into a decimal, I'm going to have to use my SD button. So 27 over 200, press my SD button, and I'm getting 0.135. And then the last one, the relative frequency of a coach, and they want the answer as a percentage. So how many coaches? 34. The total is 200. And this time, because I want a percentage, I have to multiply by 100. frequency for each outcome to 2 decimal places. Okay, now, so we're going to have to do each one here. So it's going to be 93 over 600, 104 over 600, 101 over 600, 97 over 600, 99 over 600, I'm trying to leave myself a bit of space, and 108 over 600. Okay, so 93 over 600, I'm going to do this for all of them. I'm going to use my fraction, and then I'm going to use my SC button. Okay, there's a bit of teaching in this, okay, so it says 2 decimal places. Here's the first one, and here's the second one, okay? And then I'm going to stop. I'm going to stop here, okay? That's 2 decimal places. Now, when you are doing this, when you are shortening a number, okay, so the answer in my calculator is 0.1516, and I'm not going to use the last 2 digits. So when you do that, you have to do it correctly, which means you have to round, okay? So I've decided that I'm going to use this digit here, the 1, and I'm going to use the 5. But the 5 could possibly change. And the thing that decides whether it changes is the number after this one here. Okay? If that number is 5 or bigger, the number goes up. Okay? And if that number is less than 5 or smaller than 5, the number stays the same. Okay, so there's no possibility of the number going down. It either gets 1 bigger or it stays the same. Okay, so 2 decimal places, the 1 is my first decimal place and the 5 is my second decimal place. I then have to acknowledge the numbers that I'm going to be cutting out. So I look to the next number, which in this case is a 1. A 1 is less than 5, Okay, so that is 1, 2. So I'm actually not cutting anything out of this number, so I don't need to do anything. That's just 0.18. Okay, now that's tricky, okay? You need to maybe look back over that a couple of times and see if you can figure out where I'm getting my numbers from. Okay, but in the pink boxes you can see my 1, 2, 3, 4, 5, 6 answers. Part C then says, do you think that the die is biased? And give a reason for your answer. Okay, so remember I said that in order for a die to be unbiased or fair, then all of the relative frequencies must be the same. All of the events must be equally likely. Okay, these numbers are not all the same. Yes, I got a couple of 0.17s, but I got a 0.18 and a 0.16 and a 0.15. So I would say outcomes not equally likely, so die is biased, or if you prefer the word unfair. Okay, it's only fair if all those numbers are the same and all those numbers are not the same. Okay, so there's quite a bit in that. Take your time, go through it. Please make sure you correct your mistakes and let me know if there's anything you still don't understand. Alright, for now I'm going to move on to the next thing, which is theoretical probability. Now, this is what I've been going on about, okay? Relative frequency, which is what we've been doing so far, is based on an experiment. Okay, remember we were talking about the coins, and I said it's meant to be half and half for heads and tails, but sometimes it's not, because when you actually flip a coin 10 times, you don't necessarily get 5 heads and 5 tails. Theoretical probability is about the half and half. Theoretical probability is about if you flip a coin, because there's 2 sides, then you have half a chance of landing on one side and half a chance of landing on the other side. So this is not based on experiment, this is based on theory. Okay? You do it the same way, you can see it here, still a fraction. Okay, so make sure you're taking this down, your heading is theoretical probability, write down this fraction, the number of outcomes of interest over the total number of outcomes. So it's always the top line, what are you interested in, the bottom line, total. Always the same. Okay, so we'll have a look at an example. Again, example 8.16 is what goes into your copy. A fair 6-sided die is rolled. What is the probability of rolling a 4? So the event I'm interested in is rolling a 4. So how many 4s are on a dice? There's 1 4. Over, what are the total amount of numbers on a dice? There are 6 numbers on a dice. So if you roll a dice, the chances of getting a 4 are 1 in 6. Okay, again, that's theoretically. Okay, 1 in 6 times you should roll a 4. So that's the difference between an experimental probability and a theoretical probability. Here it doesn't matter. I'm not going to actually ask you to roll the dice. I just want to know how many 4s are there on a dice. There's 1. And how many numbers are on the dice? There's 6. That is the probability. Okay, we'll try another one. So example 8.17 goes into your copy. A bag contains 2 red, 2 red, 3 green, and 5 blue marbles. Okay, there they are. A marble is picked at random from the bag. What is the probability that it is red? Now they ask us to give our answer as a decimal, so we'll have to remember that. But what is the probability that it's red? So how many red marbles? The event I'm interested in is red. So how many of them are there? There's 1, 2. And the bottom line is always the total. So how many are there in total? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles in that bag. Okay, that is the answer, except that it's a fraction and they specifically want a decimal. So we use our fraction button to type it in and we use our SD button to change it. So it's 2 over 10 SD, and we get 0.2. Okay, and we'll try one more. Why not? So a card is drawn at random from a standard pack of cards. So if you remember, a standard pack of cards has how many cards? 52. What is the probability of each of the events, of each of the following events? Now, if you are forgetting these numbers, you can go back to that question in your book right at the start of this chapter where there was a deck of cards drawn. Okay? So the probability of getting a red card. So there are 26 red cards. So the event I'm interested in is the red card, and this is how many there are. And then the bottom line needs to be the total, and here's the total over here, 52. Now, it says in each case, give your answer as a fraction in its simplest form. So the fraction is fine, but we need to check if it's in its simplest form. So to do that, we use this button in the calculator and press equals. And if you do that on your calculator, it tells you that that fraction is the same as a half. Part B. What is the probability of getting a heart? Okay, so if you remember, a heart is one of the suits, and there are 13 of each of the suits. Okay, so there are 13 hearts. Hearts is the event I'm interested in, so it goes on the top of the line. The bottom is the total, which is 52. Again, we need to check if that's in its simplest form. So we type it into our calculator, and we find out that it can be simplified to a quarter. Next, probability of getting a 7. Okay, so 7, getting a 7 is the event I'm interested in. So how many 7s are there? There's 4 of them. So that goes on top. The bottom, again, is your total. That is your answer. We need to check if it's in its simplest form. So we use our calculator, and we get 1 over 13. And the last one is a picture card. So we spoke about picture cards. They're your jacks, your queens, and your kings. So there are 12 of them in total. And again, that's picture card is the event we're interested in. There's 12 of them. So 12 goes on the top of the line. And the bottom, again, is your total. So 12 over 52, can that be simplified? It can. It's 3 over 13. Okay, so that's how you do theoretical probability. Nothing to do with actually having a deck of cards or, choosing 10 cards or anything like that. It is literally just based on theory. So it's based on how many red cards are there, how many hearts are there, how many 7s are there, okay? And you just create your fractions. Okay, so I'm going to give you a couple of them to try for homework. Same again, please try them, please upload them to Schoology, and I can have a look at how you're getting on. And let me know if there's any issues. Okay, have a good weekend.